Student, in the previous classes we have discussed about the kinematics. So basically kinematics is the branch of physics in which we deal with the motion of a object or study the motion of a object without considering the force acted upon it. So basically the main ingredient of kinematic motion are the velocity, acceleration and displacement. So let's write the definition of kinematics. So kinematics is the branch of physics which deals with the study of motion of the object without considering force acted upon it. So the main ingredient of this kinematics motion are the displacement. As it is a vector quantity, we are representing a arrow headed on the top of S. Velocity, and acceleration. And all the three quantity are function of time. They are changing with respect to time t. So let briefly discuss about also the equation of motion. Equation of motion basically the relation between the velocity, acceleration, displacement, time. So first equation of motion is v is equal to u plus at. You can clearly see that velocity, acceleration are the vector quantity, displacement are the vector quantity, but time is a scalar quantity, so we are not giving arrow on the top of the time. And second equation is s is equal to ut plus half at square. And third equation is v square is equal to u square plus 2a dot s. You can see that there is a dot product clearly indicating between the displacement and acceleration vector. So in the three dimension, the velocity can be written as v vector is equal to vx I cap plus vy j cap plus vz k cap. Similarly, u vector, which is the initial velocity, and v vector is the final velocity, so we can write that it is final velocity of a object, and u is the initial velocity, so it also can be written as uxy cap plus uyj cap plus uz k cap. I cap, j cap, k cap are the three unit vector in the direction of x, y and z respectively. So u is the initial velocity. Similarly, acceleration can be written also ax I cap plus ay j cap plus az k cap, where ax is the x component of acceleration, ay is the y component of acceleration, and az is the z component of acceleration. Here you can see that v square, writing v square is same as v vector mod square. So v vector mod square can be written as vx square plus Vy square plus Vz square. So all these things we have already discussed in the previous classes, and dot product between the a and a dot s can be written as ax I cap plus ay j cap plus az k cap dot dotted with sx I cap plus sy j cap plus sz k cap. So we can know that then in case of dot product, I dot I is 1, j dot j is 1, and k dot k is 1, and other combination are 0. So ax sx plus ay sy plus az sz. So these are the basic preliminaries of the vectors quantities involved in the kinematics. So we have all this already discussed in the previous classes. So today we are going to do some interesting problem based upon the kinematics. One of the vast application, it has many fields like defense and other research areas. So dear student, I simply ask one question. Let's take a ball in the hand and just drop from some height. Let the height be the h. What you will observe? The ball will reach to the ground, as earth has some gravitational force, so it will be attracted towards the gravity with some constant acceleration g. So basically this type of motion is known as the free fall, and it is taking place in one dimension. Okay, so it is an one dimensional motion. Just you have picked the ball and it will be placed some height edge, and you will be release it from height edge. Then the motion will be simply a straight line motion and taking place in one dimension. Okay, let's discuss some one of the interesting problem. Let you take a ball in your hand and projected with some initial velocity, making your hand theta with your horizontal, then you can see that this type of trajectory will be occur. You can see that clearly. So basically this type of trajectory is quite interesting trajectory. In physics we have named it as projectile. What is this? Is named as projectile, and this type of motion is known as projectile motion. Okay, so when the motion is said to be a projectile motion, so the basic definition will be, if a particle is projected with some initial velocity which is making an angle theta with horizontal. Then the motion is known as projectile motion. So basically it is a two-dimensional motion, 2D motion. It is known as two-dimensional motion. It means the motion is takes place both in x direction and y direction. Let's simply first we draw some coordinate system. This is let x axis and this is known as y axis. Okay, let the projectile is projected and the trajectory will be look like parabola. With some initial velocity it will be projected u, and it is making an angle theta with the horizontal. Okay, as we have previously discussed from the vector resolution in the chapter of vector, scalar and vector, if any vector in two dimension can be resolved into two component, so one is the horizontal component and another is the vertical component. So horizontal component can be resolved into u cos theta, so it is the ux component, and uy component will be u sin theta. Okay, so in projectile motion in the day-to-day real life world, the trajectory will be look like this. This will be not perfect parabola, it will be fall sharper, and the shape of this parabolic shape, it depend upon the air resistance and various friction force. So in your diploma syllabus it is not included, but in a higher study you will know that there is some resistive force will oppose the motion of this projectile. Due to this, the shape of exact parabolic shape will be destructed, and the dissipative or frictitious force for that will be proportional to velocity, and it as it opposes, so the negative sign will become with some constant. So this type of equation you are going to deal in future, but in our cases we simply neglect the air resistance, and other frictional force in this case, and other frictional force. Why we are dealing with all these things? Because to make the calculation easy, to make the calculation and derivation quite simple. Okay, so before going through all the derivation, let's again draw the projectile. It is the x-axis, this is the y-axis, and it is projected with some initial velocity u. Unless and until it will be projected, then it will be, this motion will be simple the case of free fall that we have previously discussed, and the motion will be not two dimensional, and it will be simply one dimensional motion. So we have to give some initial velocity and projected with some angle theta with the horizontal. Okay, so ux component can be written as u cos theta, as it is an horizontal component, and vertical component uy is equal to u sin theta. Okay, it is the maximum height attained by the projectile. So the motion is along y direction, so height is also in y direction, and the horizontal distance cover, this is known as technically range of the projectile, so it can be symbolized as r. Okay, and to complete the journey from initial to final point, the total time is required, that is known as the time of flight. So time of flight consists of two components, that is one is time of ascent and time of descent. Let time of descent can ascent can be denoted as t1 and time of descent is t2. Okay, so as the projectile is moving in both x and y direction, but the actual acceleration of the projectile is taking place in the y direction. So we can write that acceleration vector is equal to ayj cap, and for the convention and calculation easy, we have taken if the projectile is moving in the upward, it is going against the gravity, so we can define as the acceleration ay component is minus g, and it is falling towards the earth, then ay can be written as plus g. And this is the sign convention that we can use for calculation, made simpler. So first we going to derive the equation of time of flight. So it is denoted as capital T. So again we have to draw a projectile for simple understanding. This is the initial velocity u, which is making an angle theta with the horizontal, and ux component is u cos theta, and ui component is u sin theta. Okay, so this is the highest point. And first, time of flight will has two component, that is t1 and t2, time of ascent and time of descent. So first of all we are going to derive the time of ascent, t1. Time of ascent is the time required to from position O to A, time required to attain the distance of OA. So you can clearly see that at the point A the velocity is 0. If the velocity is not 0, then it will be at the projectile will be attain some height also at that point, it will be not back to the ground. So at the highest point the velocity is 0. You can take also the example, if you take in the one piece of chalk and throw upward, then at the highest point if the velocity is 0, then it will be start returning to the ground. So you can simply do this type of experiment in class also, it is quite simple. So time of descent is actually taking in y direction, so we have to be considering the motion along y direction. So we use the first equation of motion, that is Vy j cap is equal to Uy j cap plus Ay j cap into t. This is V is equal to U plus At. In y component are there and other component are 0. It is taking place in y direction. Final velocity is 0 and initial velocity is Uy is U sin theta j cap, and acceleration as it is going upward, so we can take the negative g, acceleration is negative g, so time is t1, time of ascent, so t1 can be written as u sin theta by g. This is the expression of time of ascent. Okay, similarly we are going to derive the time of descent. So time of descent t2. So how can we derive that? You can simply qualitatively you can find that as the system is a non-dissipative system or a conservative system or you can say that it is we have neglected the air resistance. So time of descent T2 also same as T1, so it is u sin theta by g. But for sake of completeness, we also can derive the equation how u sin theta by g has come. You can see clearly that at the point the velocity is g, so we have to be found what is the velocity when it hit the ground. So you can clearly see that this angle is theta, then this is 90 minus theta. As these two lines are parallel to each other, so this angle also 90 minus theta, which clearly indicate that this angle is theta, and this angle is also theta as it is an opposite angle. So we can proceed the next step, that is, if it is theta, then you can find this is u cos theta, and we can write that this is u sin theta. But at it is coming in the negative axis, so we can introduce a minus sign here, that is minus u sin theta. Let's write the equation again. Vy j cap is equal to ui j cap plus ay j cap into t2. T2 is the time of descent. Final velocity will be minus u sin theta at as it is the y component we are only taking, and initial velocity is 0, and acceleration as it is going upward at that point, so it will be time t2. So t2 will be simply u sin theta by g. So this is the simplest expression that we can find using the kinematics equation of motion. Okay, simply for that we can initially the velocity will be 0, and at that point when it hit the ground the velocity will be minus u sin theta. Okay, so total time of flight t can be written as, so simply t is equal to t1 plus t2, it will be 2u sin theta by g. Okay, this is the expression of time of flight. You can clearly indicate that it will be depend upon the initial velocity and the angle of projection, that is the theta. So when the time will be maximum, when to required to complete the trajectory, so t will be maximum when sin theta will be maximum. When sin theta will be maximum, as you can clearly state that the range of the sin theta is -1 to 1, as you have solved in mathematics class and saw in the trigonometry chapter. We can also draw the graph of the sine function. So the maximum value lies between the 1 to -1. So this is the range of the projectile, a range of the sine function. Okay, so for the maximum sin theta will be 1, and when the sin theta will be 1 at sin 90 degree, so comparing this theta and 90 degree, so theta will be 90 degree. So t will be maximum when we projected when we project the projectile at an angle theta is equal to 90 degree. It is quite obvious when you take a chalk and just throw upward making an angle 90 degree with the horizontal, then the trajectory will be look like it will be go upward and it will be reverse its path. So basically the time will be maximum in this case, but when the angle is not 90 degree it will be just cover the path, it will be not reverse the path also. So in case of a projectile is projected at 90 degree, obviously the time will be maximum. Next we are going to derive the height of the projectile. So from the projectile figure you can clearly see that actually the height is taking place along the y direction. So we have to be take the motion along y direction. Okay, so we can write considering the motion along y direction, so we can use the equation of motion among three equation of motion. We can use the third equation of motion for simplicity. V square is equal to u square plus 2a dot s, as it is taking in y direction, so we can simply write at vy square is equal to ui square plus 2 ay sy. So the final velocity at the highest point is 0, initial velocity is u sin theta, so squaring the u sin theta, u square sin square theta, it will become plus, as it is going upward so we can take that it is minus g, and sy is the height, so h will be u square sin square theta by g by 2g. Here also you can see that the height is depend upon the initial velocity and the angle of projection. So when the height will be maximum, simply we can solve that height will be maximum when sin theta will be maximum. So the value of sin theta range lies between -1 to 1, as we previously discussed about in the case of time of flight. So maximum value of sin theta is 1, which value is sin 90, so theta will be 90 degree. So when a projectile is projected at an angle 90 degree, then it will be attain the maximum height. The same thing you can do that, hold a piece of chalk and throw it upward making an angle 90 degree with the horizontal, then it will be attain the maximum height and it will be revert back to the original position or to the ground. Okay, you have solved the time of flight and height for the projectile. Last expression is the calculation of range. It is denoted as capital R. So from the figure you can also see that it is the horizontal distance travel in the x direction. So this is the horizontal distance, travel in x direction. So to derive the expression for the range of the projectile, simply we can write second equation of motion, that is s is equal to ut plus half at square. As the motion is taking place in the x direction, so we can simply write that sx is equal to uxt plus half axt square. As we can know that there is no acceleration takes place along x direction, so x is 0. Actually the acceleration is taking place due to the earth gravitational force or acceleration due to gravity only in y direction. So this expression can be simply reduced to ux into t. So sx means the distance covered in the x-axis, that is the range we have defined already, and ux is the x component of velocity, that is u cos theta, that is the initial velocity, and t will be the total time of flight to complete the journey. To more illustration, let's once again draw that. It is the horizontal distance known as range, and total time required is time of flight, and u is the initial velocity which make an angle theta, and it has two component. Ux component is u cos theta and ui component is u sin theta. Okay, so in previously we have derived the equation for the time of flight, that is 2t is equal to 2u sin theta by g. So let's solve it. U square is outside, that is u sin theta cos theta by g. In trigonometry we have already studied that 2 sin theta into cos theta is known as sin 2 theta by g. This is the expression for the range. When the range will be maximum? So the range will be maximum when sin theta, sin 2 theta, here 2 theta is the expression, not theta, there is 2 theta is coming, so 2 theta will be maximum. So sin 2 theta maximum value is 1, so this equal to sin 90. So we can simply write that 2 theta is equal to 90 degree, so theta is equal to 45 degree. Okay, so if the projectile is projected with an angle 45 degree with respect to the horizontal, then it will be travel more along the x-axis, that is it travel a more range. Okay, let's mathematically prove that the equation for the motion of the trajectory is parabolic in nature. So for that we can simply write that, so given topic, that is equation of trajectory. So along the x direction we can write the simply equation of motion is equal to uxt plus half axt square, already we have discussed, and acceleration along the x direction is 0. So sx can be written as x is equal to ux is u cos theta into time t. So t can be written as x by u cos theta. This is the expression for time t. Similarly, sy is equal to uit plus half ayt square. So sy is equal to y, ui is equal to u sin theta into t minus, as acceleration is negative direction, as the projectile is projected upward, so we have taken as ay is negative of g, so this will be the corresponding expression. So simply we can put the value of t from equation 1 to equation 2. So this will be become u sin theta x by u cos theta minus half g x square u square cos square theta. So u has gone, so this will be x tan theta minus half g x square by u square cos square theta. So this is the relation between the x and y coordinate, and this will be confirm the trajectory of the projectile. And what we have done in this case, we have eliminated the time coordinate and we have find the relation between the x coordinate and y coordinate. Okay, simply you can see that before drawing the graph of this type of function, we basically discuss some basic function. Let's show that y is equal to x square. This is a simple graph. This type of graph is known as the parabola passing through the origin. So this is upward parabola. Parabola and passing through the origin. This is y axis, this is x axis. But if we introduce a negative sign, then it will be revert to the negative axis, and the parabola will be known as the downward parabola. Simply introduction of this negative sign. So this is known as downward parabola. Okay. So here also you can see that there is a negative sign in this case. You can clearly see this is negative sign. This negative sign is there. So for this negative sign, the parabola will be downward. And we finally confirm the mathematically that the actual motion of the projectile is parabolic in nature. So what we have discussed in this lecture, basically we have solved one two-dimensional motion problem that is known as the projectile, and for the projectile we have find the expression of horizontal range and height and total time of flight. So these are the three expressions we have find, and finally mathematically we try to prove that the motion is actually taking place in xy plane and it is parabolic in nature. And some important tasks that we are giving to all of you, that in the starting lecture we have also clearly written that we have neglected the air resistance and other frictional force in this case to make the calculation is quite simpler. But as a curiosity or your knowledge, enhancement of your knowledge, so you can also introduce the frictional force into this problem and try to solve the equation of motion and compare the trajectory for this case also. So dear student, what will be the projectile for this case? It is quite obvious that it will be fall faster. As you can see in this figure number 1, you can see that this projectile will be fall faster in that when we introduce the frictional force in this case. So you have a one of tasks that how to introduce a frictional force, you can think that, and if you try to solve it for your better enhancement your knowledge and learning activity. Thank you.